Okay, so last class we finished the Math 10 review, and we started in on the Math 11 curriculum. And the big thing to take away that we reviewed is slope-intercept form. Okay, so y equals mx plus b. And even when we have an inequality sign instead of an equal sign, we still want it in that slope-intercept form. So we still want y equals mx plus b. So if we rearrange this, we get y by itself, and then we rearrange to get it into mx plus b form. And then anytime here we have a negative y, so we're going to either multiply by -1 or divide by -1. And in class I divided by, so here I'll multiply, so times -1. And rainbow that out to everything in the equation. So we'll have y, -1 times -2 is 2x, and minus 6. And then remember the rule here, whenever we multiply or divide an inequality by -1, we have to flip the inequality sign. So we flip it, and there we go. And here's the rule written down. And again, this is an important rule. It will make a huge difference moving forward. Okay, so anytime you multiply or divide by -1, flip the inequality sign. We'll move into graphing linear inequalities with two variables. So we graph a linear inequality just like we graph a linear equation or a line. Okay, so first we'll make sure it's in mx plus b form. And so if we look at our inequality here, y is greater than or equal to 2x plus 3, and so that is y equals mx plus b form, so that's good. And then when we graph that, we know that the line will form the boundary of the linear inequality, and we'll talk about that a little bit more, but for now let's graph the line. So if I look at the line, here's 3, that's my y-intercept, so 1, 2, 3. And then my slope, so b is 3, and m, which is rise over run, will equal 2 over, remember that every number is imaginarily over a 1, so 2 over 1. So we'll go up 2 over 1. And remember that this is a positive slope because it's just 2x, so my line should look like I have to walk up a hill. So I'll go up 2 over 1, up 2 over 1, up 2 over 1, and the other way, down 2 over 1, down 2 over 1, down 2 over 1. And I'll draw in my line. Again, your line should be neater than mine. And keep going. And this is my boundary. So this line is the boundary. Okay, and because it's y is greater than or equal to 2x plus 3, x plus 3, so it's anything greater than, we will shade above the boundary line. Okay, and we'll talk about the rules for that on the next page. And because I've drawn arrows on the ends of my line and we have not been given any restrictions, we will assume that x is all real numbers and y is all real numbers. And since the range domains aren't stated, so we weren't given a set notation, we assumed, like we wrote here, that domain and range are the set of all real numbers. So the solution set, because I've joined these data points and I have a solid line, is this continuous or discrete? Hopefully everyone said continuous. Okay, and then the line we graphed above, so this line that we put in, do you remember what we called that? And I wrote it on here. We called it the boundary. Okay, so this is called the boundary. so let's look at some rules for the boundary. So when we look at the boundary, which is a line, we know what kind of line to draw by the inequality sign. Okay, so the inequality sign, just like it told us what kind of dots to draw in our number lines, it tells us which kind of line to draw. Okay, so we have less than or equal to, and then change this one to greater than or equal to. Okay, so we have less than or equal to or greater than or equal to. When you see that equal to, you know that you have to draw a solid line. Okay, a solid line, because the solution could be part of that line. Not necessarily, but it's a possibility. And then when you have less than or greater than, you will use a dashed line. And these last two are known as strict inequalities. Okay, they're strict as in it's only above or below the line. The line is not included in that. So if we look at these examples here, y is greater than or equal to 2x plus 3, what kind of line would we draw? So if we look at the sign, draw your line. And then for the one below, y is greater than 2x plus 3. Here we have that sign. So what kind of line we will draw? Will we draw? And up here, the first one, we will draw the boundary as a solid line. Okay, so this will be a solid line. And then this one here, y is greater than 2x plus 3. We will draw boundary as a dashed line. Okay, and so just a dashed line like that. And then we have something called the half plane. Okay, and the half plane is the shaded region of the graph, and that's either above or below the boundary line. So if we go back to our example that we did here, this part here that's shaded will be the half plane. Okay, and we'll figure out where we want to draw that now. Okay, so the half plane is the shaded area of the graph, and it will either be above or below the boundary line. It can't be in both. And the inequality sign will tell us that possible values, and the values will be given in coordinate form. Okay, so x comma y either fall on the boundary and or on one side of the boundary. Okay, so they can fall on the boundary if you have a solid line, and then they can fall on either side of the boundary. And we always have to shade one side of the boundary. So you'll decide by the inequality sign again. So if y is greater than or y is greater than or equal to, you will shade above. So here's your example here, and we'll just draw any random line. So greater than or equal to, we shade above. If y is less than or equal to, we will shade below. Okay, same line. Now we shade below. And I've drawn solid lines. So the solid line is indicating that I've used less than or equal to in this example and greater than or equal to in this example. And again, if we go back to our example on the last page, you'll see that our inequality was y is greater than or equal to 2x plus 3. So the greater than or equal to tells us both that our line will be solid and that we shade above the line. Okay, and that's what we did. Okay, so for boundary, again, the inequality sign tells us what to do. Is it solid or is it dashed? And the inequality sign also tells us where to shade. So where is our half plane? And you'll notice it's called a half plane, so you'll only ever shade half of the graph. So let's do this example here. Y is greater than or equal to 2x plus 3. You'll notice that this is the same example as before, but that will be good because it's good practice. So again, identify, am I in y equals mx plus b form? Yes, so we can go down on this one. So b will be 3 and m is 2 over 1. So we go up 3 and then we plot our graph. Oh, whoops, not there, there, and there. We draw our line. Okay, we know to draw a solid line because we have a greater than or equal to sign. And then we know to shade our half plane above the line because it's greater than or equal to. So we'll shade above the line. We weren't given any restrictions, so we are assuming, what can we assume with no restrictions? We assume that x is all real numbers and y is all real numbers. Okay, and then the solution set, okay, and the solution set is just our way of saying what is a possible solution for this inequality. Solution set is the shaded region and the boundary. And the boundary is included because it's a solid line. So it's a possibility that that is included in the solution set. Okay? And we find the solution set basically wherever the graph is shaded. Okay? So here we have y is less than or equal to x. So again, we look, is this in y equals mx plus b form? It is. And in this case, our b will be 0. Okay, so there's no b written here, so b is 0, and then m is 1 over 1. So we'll start at our origin. Remember, our origin is 0, 0. And we'll just go up 1 and over 1. Again, we have a positive slope, so if you're on the graph, you should be walking up the graph. And you draw your line. And I've done something. No, I haven't done anything wrong. Good. So we have a greater than or equal to inequality, so my line should be solid. That's good. And again, we were given no restrictions, so we're assuming x is all real numbers, y is all real numbers. And that's our assumption. And again, the solution set is, so what's the solution set? So let's look at our sign to know where we shade our half plane. Less than or equal to, and if we go back to our half plane rules, less than or equal to, we will shade below. We'll shade below. So if we go back, here we go, less than or equal to, we shade below. And you'll see in the textbook that the shading is very nice, and they actually shade the whole thing. And you can do that with your pencil if you want. It's difficult for me to do it with the smartboard, and that's why I don't do it. But the solution set in this case is the shaded region. And the boundary. Again, because we have the solid line, the boundary is a possible solution. Okay, and then one more example. Y is less than negative 3x plus 1. Again, are we in y-intercept form? We are. And b equals 1, and m equals negative 3 over 1. So let's plot our graph. And we start at 1 and we rise. So it's -3, so we'll go down 3. 1, 2, 3, and over 1. And this is a negative slope, so I should be walking down the hill. And we go 1, 2, 3. Okay, and to go up, we go the opposite way. Now, let's look at our inequality again. Here we go. Y is less than -3x plus 1. And so in this case, our boundary will be y equals -3x plus 1. And that's the line we just plotted. And we will have what kind of line here? Hopefully you said a dashed line. And so let's fill in our dashed line. Okay, our dashed line. And we can add little arrows to that. So if we look again at the inequality, it's less than or equal to, which means we're going to shade below the line. So in this case, because it's a negative slope, below the line is over here. Again, we're given no restrictions, so we are assuming that x is all real numbers and y is all real numbers. And then the solution set is the shaded region only. Okay, we do not include the boundary line because this inequality is less than, not less than or equal to. Okay, and the last thing, we're almost done. We're just going to cover test points here. Test points can be useful to check which side to shade. So the inequality tells you which side, but if you're unsure, you can always use a test point. And the easiest test point to choose is 0, 0, because it just makes everything nice and clean. So if the test point is a solution to the inequality, so if the inequality is true when you use the test point, then you shade the half plane that contains the test point. Otherwise, if you put the test point in and the inequality is not true, you shade the other half plane. So for the graph above, we'll test the point 0, 0. So then we just enter, this is x and this is y. So for y, we'll put 0 is less than -3 times 0 plus 1. So 0 is less than plus 1. And that's my test point solution. Is this true or not? It is true. It's true. So this is a, therefore, this is a valid solution. Okay, and then we will shade half plane that includes zero, 0. Okay, so let's go back to our graph and we'll look here and let's find 0, 0. So here's our origin. And you'll see that the origin is in fact included in our solution set. Okay, and just to test it to see what it would look like if the solution is not valid, let's choose 1, 1 and do the same thing. Okay, so just do it over here. If we test 1, 1, we have 1 is less than -3 times 1 plus 1. So 1 is less than, and we have -3 plus, oh, sorry. That would be the answer, but plus 1. So then 1 is less than -2. And that is not true. This is false. So if it's false, we have to shade the other half. So we cannot shade that point, and you'll see that that point here is not shaded. Okay, so the test point really helps. If you can use 0, 0, for sure use it. It makes everything a lot easier. And then the very last section here is the solution region. Okay, and this is that part that we were shading and where we were writing the solution set. So this is the part of the graph that represents the solution set for the linear inequality, or values that satisfy the linear inequality. And if we look above here, 0, 0 is a point that satisfies the inequality. So the solution set can be just the shaded region, okay, and that's when we have signs like that. And the line would be dashed. And anyone remember what we call this inequality? These are strict inequalities. Okay? Or it can be the shaded region and the boundary. So if you see a sign like this and you see a solid line. Okay, so if you have y is less than or y is greater than, again, these are our strict inequalities, then we use a dashed line for the boundary. And the solution set is the shaded region only. Okay, so shaded region only, and I'll just draw my line in there. So the solution set cannot include the boundary. Okay, and then here if you have y is less than or equal to or greater than or equal to, you use a solid line. A solid line. And here you shade, or the shaded area and the boundary set, sorry, boundary and shaded region. Form the solution set, or are included in the solution set. Okay, and we went back and we had defined the solution set as we went along, but you can go back and test to see if it's true. Okay, so the shaded region only because we have a dashed line. Okay, so go back and check them all, make sure you understand where we're going with that. And then for today, where are we? We'll do this graph. Okay, you were handed this graph in class, but I will also post a copy of it. This is the only video for this week. And then don't forget that we have a quiz on Tuesday. And this is based on the Math 10 review. So nothing from the notes package that we're working in right now. Nothing from the 6.1 notes. It will all be from the 6.0 notes. Okay, so don't forget to get your worksheets done, watch the video, and we have a quiz on Tuesday. Please be on time. Be here at 9 a.m. Okay? It's disruptive for people when you come in late to a quiz, and we want to make sure everyone feels comfortable while writing the quiz. All right, so I'll see you guys Tuesday, and have a good weekend.